This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 6, Infiltration Loads. Infiltration is the outdoor air you never asked for. It leaks through cracks and gaps in the building envelope, driven by the temperature difference and by the wind. We'll name those two forces. Build the leakage area airflow the handbook prints. Then convert that airflow into a sensible and a latent load. Concept 1. The two drivers. Infiltration is leakage, not ventilation. Outdoor air sneaking in through cracks versus air you deliberately bring in through the system. Two forces push it. The stack effect. Warm indoor air rises and slips out high, while cold air is drawn in low, driven by the temperature difference. And wind. It pressurizes the windward wall, pushing air in, and depressurizes the leeward wall, pulling air out. The handbook prints one method for this, and it is residential. Concept 2. The equation. The airflow equals the effective leakage area times the square root of a stack term plus a wind term. The leakage area is a property of the house, taken as given. The stack coefficient and the wind coefficient come from tables, keyed to how many stories the house is and how sheltered it sits. Notice the two drivers we just named sit right inside that root, the temperature term and the wind squared term. Concept 3. From flow to load. Once you have the airflow, infiltration is just another airstream, so the standard air factors from Lesson 1 do the rest. 1.1 times flow times the temperature change for sensible, 4840 times flow times the humidity ratio change for latent, and add them for total. One warning, don't double count. That window and door air leakage term back in the fenestration lesson is the very same leakage. Count it once, in one place, not both. Setup. A one-story house, leakage area, 80 square inches. Winter design, 70 inside, 10 outside, so a 60-degree difference with a 15-mile-per-hour wind. It sits across the street from other buildings, shelter class 3. From the tables, the stack coefficient is 0.0150, and the wind coefficient 0.0065. We'll carry a humidity ratio difference of 0.004 for the latent side. Solve. Part 1. The airflow. Drop the numbers in. The stack term is 0.9. The wind term is 1.46. Under the root, that sums to 2.36, whose square root is about 1.5. Times the 80 square inch leakage area gets roughly 123. Notice the wind term outweighs the stack term at this wind speed. Solve. Part 2. The loads. 1.1 times the airflow times the 60-degree drop is about 8100 sensible. 4840 times the airflow times the humidity ratio difference is about 2400 latent. Add them, roughly 10,500 total. That's the infiltration burden. Heat to warm the cold air, moisture to rehumidify it. Traps. 5 of them. 1. The handbook gives only the residential leakage area method. No air changes per hour on the exam. 2. Don't double count. Window and door leakage from the fenestration lesson is this same air. 3. The leakage area is an area in square inches, not the fenestration flux in CFM per square foot. 4. Both driver terms live under one square root. You can't split them. 5. 1.1, not 1.08, and keep the units the tables expect. Quick recall. Infiltration is driven by stack and wind together. Build the airflow from the effective leakage area and the square root term, using stack and wind coefficients from the tables. Then load it with the standard air factors, 1.1 for sensible, 4840 for latent. The handbook prints only this residential method. Golden rule. Count the leakage air once and never also bury it in a fenestration term. Next up, Lesson 7. The ventilation load. Same standard air factors, but now the airflow is deliberate. A known outdoor air rate you push through the system, plus the mixed air temperature when outdoor and return air blend. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.